Good afternoon, everyone. Let's all welcome Gavin Roy, who's going to teach us how to become a logging expert in 30 minutes.
Thank you. I have to say, it's pretty cool being at the end of PyCon or the next to last talk track because I've got to see lots of really cool material, so I hope I live up to a lot of the talks that I've already seen. How do you become a logging expert in 30 minutes? Well, it's hard to do, but what I want to do is I want to dive into the logging module, something that oftentimes people tend to touch, do things with, but maybe not understand the full stack of everything that's going on. And so I have a lot of information here. I'm going to try and squeeze it down to 30 minutes. And if I rush through some things, I apologize. I'm happy to answer questions after. I work for Meet Me. We are a social network focused on social discovery, and we're located on the East Coast, and we're hiring, and they were nice enough to send me here and sponsor PyCon, so if you're looking for a job, you're interested, please get in touch. The content examples and SVGs from my talk are hosted on GitHub, so as we go through the examples, again, if it's too quick or you want to check something out later, feel free to go over to that and grab it. Why should you use logging? The number one reason is it's highly configurable. And in fact, it's so configurable that some might say it violates the Zen of Python because it can be complex. And it can be complex to the point where it's intimidating. But you might see this common pattern in things. I actually went to one of the oldest apps I wrote in Python and published on GitHub and pulled code out, and this was the code. You can see I've got commas, for example, in my exceptions, so that probably shows you that it's older than it should be. But what I'm doing, as you can see, is I'm printing when I want to debug things. I'm writing to standard error when I have an error, and you know, that's good for running things interactively, but when it comes to putting your app in production, that doesn't work very well. So one of the nice things about logging is it provides a consistent output method. This same code refactored allows me to send debugging information to a place that I want debugging information to go, exception information to a place where exception information should go, and error information to somewhere else as well. Another nice feature about logging is it allows us to avoid not invented here syndrome. I was working on fixing some issues in a very well-known Python application, and I saw that they had logging.debug, logging.warn, logging.info. I'm like, awesome. I'll go in and I'll just figure out where they're instantiating their loggers and fix that and get the logs go where I want them to go and logged how I want them to go. Well, they decided somewhere in the life of their project that they didn't like the logging module, and so they wrote their own. And it was hard-coded to write everything to one file on one path, and you couldn't change anything about it. Another nice feature is the fact that it has configurable destinations, and that was one of the things I was trying to achieve was fixing in this project, allowing for configurable destinations for the various things that I wanted logged. I wanted exceptions to go into a specific file, so it was easier for me to figure out what's going wrong and fix it. And I wanted informational messages to go into syslog, so I could use Splunk to go and figure out trends within the application and that sort of thing. So if you just look around this, you can see you can send to everything from files that rotate on disk, to syslog. There's email in here, which I'll touch on a little bit later, HTTP. Many, many different places to send your output. Format. Everybody likes their logs outputted in different ways. Logging allows you to specify different configuration formats. And it uses the standard string formatting operations within Python. There are lots of attributes available to you when you are logging, and it allows you to do per destination conditional formatting. So I can log to syslog one way, and I can log to files another way, and it allows me to highly tailor where information coming out of my application is going. I can also filter content. So I may be sending lots of information into the logging module, and within specific destinations or places I want my logs to go, I can actually filter out things I do not want to be logged. It's an easy-to-use API for debugging your application, running your application in production, and providing internal runtime state information that may help you from a performance perspective or a behavior perspective in seeing things in your environment that you don't see when you're writing the application. You can also use it to trigger alerts when certain conditions happen in your code and provide that information to you in ways that go outside of log files or syslog. And it's an interesting way to share internal application state data, such as performance metrics, with services outside of your application. And I'll touch on that in a little bit. The logging module has various levels, everything from debug to critical. And in that range, when you're working with it, if you tell it that you want all info level items to go into a file, you're also saying you want all warning, all error, and all critical information to go into that file unless you filter that content. So it works in a system where everything is incremental based upon the previous setting that you had. In line with the Zen of Python, the logging module is all about namespaces. This is one of the very awesome things about the logging module. This means that when I distribute my application or my library, for example, Pica, which is an AMQP driver, everything is namespace that it does within the logging module. That means that users of it can say, I want to completely ignore everything this library is saying, and it also allows them to say, show me critical information from this library and debug information from my application. And that's why it's useful for writing packages. It provides a common, well-documented method for taking that information and making it available to people using your applications and using your libraries. Users can control where the information goes, how it's formatted, and what they want to see. It reduces the amount of code that you want to use, and it makes sure that your package is more Pythonic and that it plays well with others. Have I sold you guys on using the logging module if you don't use it? All right, cool. By a show of hands, how many people actually use the logging module on a day-to-day basis? Awesome. Probably didn't have to do the sales pitch then. So the logging lexicon. There are lots of aspects to logging. At the core of logging, everything you do when you log a message goes into a log record. This log record contains all the attributes about at the time, or all the attributes of the message when it goes in, including information about the runtime state of Python, where the log message was logged from, what line number, and information like that. Next in that chain are loggers. And probably one of the things that's overlooked the most. One of the things that I've seen often is when using the logging module, especially people who haven't gone into it too far, it's easy to jump in and say logging.debug, logging.info, logging.warn. What that actually does is that gives you the root logger within the logging module. But you can create your own loggers that are application-specific, namespace-specific, sit within different parts of your application and provide different levels of context. A logger is the first actor, the first part of the logging module that decides whether or not it's going to accept the message or it's going to reject it. And it is the point of entry for all messages into the logging system. And it is really what provides that namespace level or granularity of controlling messages. Since everybody, by and large, has used the logging module, it is the object to use. No matter what you're doing when you're using debug, info, warning, error, or exception, you are using a logger, even if you're doing logging.debug. So I brought up the root logger. And there's an important detail about the root logger. The root logger is the parent logger in the logging system. Everything else is a child of the root logger. This means that the root logger has exposed to it everything going on that all of its children have. It's the fire hose logger. Now, it may ignore things because you've not configured it to include things into what you're logging, but when it comes down to it, it is the top level piece. And there's an important variable in most places where you are using a logger, including the root logger, and you'll see this in the documentation. It's called propagate. And if you set propagate equals true, what you're doing and what your operation is, whether you're configuring a formatter or you're configuring a log level info, is you're saying, take this setting that I'm giving you and apply it to every single key within the namespace underneath me. So if you say propagate equals true in the root namespace, that means it's going to apply what you're doing to everything underneath it. And when I am speaking about namespaces, I'm talking about this period delimited format, what we know from Python modules and packages as this foo.bar.baz. So when propagate equals true, I'm applying everything under foo. That means it's going to apply to .bar and .bar.baz. Now, a common thing that I've run into, I'm sure you guys have as well, if you've started playing around with different loggers and handlers, is double logging. Have people run into this? So a few people have. What's happening there is that if you have handlers that are outputting things to a file or to console, and you have multiple, each handler is putting that information to that source. And so if you have multiple loggers on a single handler, for example, both loggers, if propagate equals true, for example, could be sending that information out. Another piece of configuration going in is incremental equals true. And what incremental true means is whatever config I am passing down to whatever object that accepts it is I'm going to apply this to the pre-existing configuration. So I want to change something about a runtime state, something within the logging module, and I say incremental equals true. The pre-existing configuration is there. This is going to overlay on top of that. But it's a dangerous behavior. If loggers are already configured, especially things like the root logger, reapplying configuration with incremental equals true means it's not going to change the formatter, it's not going to change the filters. The behavior that you would expect if you were coming in from a clean perspective is not going to apply. So I talked about handlers and that double logging issue. Handlers deliver messages to their destination. You can think of a handler as nothing more as a router that you can apply rules onto. It is what is responsible for taking that message from the logger and sending it somewhere, whether it's a log file, whether it is syslog. It's the guy who's responsible for that. You can have multiple handlers for an application, and handlers are applied to loggers, and you can have multiple handlers applied to a logger. This is where you're assigning your formatters and your filters. Formatters are used for destination-specific formatting. So a formatter allows me to say, when I'm logging to syslog, I want you to log this way, and when I'm logging to a file, I want you to log that way. It takes the string that you're passing into the logger, and it's what, as far as format is concerned, and it's what's applying the internal state of the log record to the actual string that is being sent out. It is what uses the %style mapping for the variables. So a few example formats. As you can see here in the first example, we're logging the level name, the time of the logged event, the module and function name that was called, as well as the line number where the logging took place, and the message. And in the second one, I get rid of the logging level. This is one that I use for syslog, for example, because when you use syslog and you do info or error, those are attributes within the syslog message as well, so there's no reason to include it in the formatted message that I'm sending. And so here, I'm only including the process ID, the process name, and the function name, and the message. Hidden away in the corner of the documentation and in the corner of the module or in the package are log adapters. Log adapters are unique. It allows you to change the way you think about using the log module. Basically, an easy way to think about log modules, or I'm sorry, log adapters, are as a way to extend a logger and actually use it as a logger, but provide additional context information that makes its way into the formatter and makes it available to the dictionary mapping from the log record. So let's say that you have a web application and you always want to log the IP address, you always want to log the user. You can create a log adapter that gathers that information from your application's runtime state and makes it available just transparently without you ever having to add it to your logging line. So when I'm doing logging.info, I'm never passing in the IP address, I'm never passing in the username. And you use it just like a logger. So it has the warn, debug, info, etc. methods available to it. One that's a little more difficult to think about how you use when you're thinking, okay, I'm going to create a logger within a namespace, and so I'm going to apply my rules to this logger, are filters. That's because by default, filters are filtering on namespace. And so if the logger filters on namespace and the filter filters on namespace, gosh, there's not a lot of use there, but it's actually a very cool feature within the logging module. You can extend filters and create your own. So in that example of wanting to use a log adapter to always provide the IP address, you could actually create a filter to say, I only want to log things when they come from this certain IP address or this certain IP block or these specific conditions are made. And it allows your code within your application to never be concerned about the things that you're going to have to deal with logging and push that all into the logging module. So with all those different components, how do you put them together? How do you use them? This is one of the areas that I see used the least in applications, in modules. It's hard to figure out what the right way to go is, and sometimes the right way to go seems like it's really complex. In fact, I submitted a pull request to a project that I like, and I rewrote all of their logging stuff, getting rid of print debugging and informational logging, and using a full configuration-based system, and they said, we don't like this because it makes our application too complex. Well, what he meant was it made his config too complex, and I failed because I should have made the application have defaults that required no config, but instead I added a bunch of options to his config file. But there are 4 ways to add configuration. One of those ways, and the ways this project was doing it, was manually in their code. So their object would be created, it would create an instance of a handler, it would create an instance of a formatter and all those things and combine them all together. That's a pain, right? If you want to go change something, you got to pull up the code. If it's code running in production, there's no easy way to change it. And so there are really 2, with a caveat, different ways that you can dynamically create your configuration. One is dictionary-based, and the other is file-based configuration. File-based configuration is the older of the 2. Dictionary-based was added in 2.7. And then there's a socket listener configuration, and this is pretty cool. It takes file-based configuration data, allows you to have a socket listening with your application running on a thread, and dynamically update the configuration in real time. So dict-config. Dict-config allows for the configuration to be passed as a dictionary. It's great for structured config data, so if you want to store it as JSON or YAML, it can be verbose, as you can see in this example. In this example, I'm setting the things I have to set up front. I've created 2 formatters, one for syslog and one for debugging. I've got a handler for the console, I've got a handler for syslog, and I'm logging everything in the Django namespace and everything in the Psycho PG2 namespace. You can see I'm doing them at different levels. And this would be what I would consider the base level for some type of application I'm going to run out. I've got some configuration examples that are very, very, very verbose because I have some 30 or 40 different packages within my app that I want to log at different levels. And so what I've moved to using is dict-config, but I actually store it as a file in YAML. And to me, this is more succinct and easier to read. And in fact, I think when they were writing the documentation for the standard lib dict-config, they felt the same way as well because all the examples are in YAML for the most part, even though there's no default standard lib YAML parser. Using YAML is actually very easy. This is what imports that configuration file. I could have even made it a one-liner. Pretty straightforward. File config, on the other hand, uses the config parser formatted configuration files, so somewhat like any files, right? It can't use the safe config parser because it has string interpolation in it. When you're specifying your format in the config file, if you try and use the safe config parser, it will fail. And it's somewhat more verbose than YAML and format. So when I look at this, here's an example. What I've got are 3 distinct sections, just like in the dict config. And for that, we have my app logger and the syslog handler. And you've got this singular my app, singular syslog. It takes a little bit of work to reference everything. Again, these examples are on GitHub, and I want to take a little time for messages, so I'm going to run through the rest of this pretty quick. The config listener, this example, up on GitHub, will add a config listener to your code, allow you to dynamically use this to inject the logging configuration into your running process. And the configuration for that is there. And one important piece of all that I want to show you real quick is the output. This is what's running at the top in blue before I inject the change in configuration. The green is what happens after, and you can see I've got that double logging issue going on because I was not able to go back and change that root namespace logging information after I initially did it. There's a lot of standard lib handlers built in. I suggest you go dive into each one and say, where does this fit? So if you're using file handler right now, does it make sense to use rotating file handler or even timed rotating file handler, one that looks at file size versus the time? What I like are the more novel things that you can do with a logging module like SMTP. In this example here, I've created an email logger, and I've said, when I get a message that is critical, I want you to send an email to me. And so all I'm doing is just like any other logger, I'm logging in a specific thing. And when that critical message comes, an email gets generated. One of the things that would be really cool about this, and I'll probably end up writing some code for and publishing, is a aggregating email handler so that you could say, if I get 10 of these messages within 30 seconds, let's say, send me an email with all 10 so I can look at it, but otherwise throw it out. It would be pretty easy. But in this, what I want to point out is I'm using the root logger to show what my app is doing, and my email logger is only sending email. There is a case that if my email logger can't connect to an email server, it's going to fail. So in that try except block, I am catching that exception. And that's the output of that. Using the HTTP handler, very similar, almost the exact same code base. And what this is doing is every time there is a logged message, it's making an HTTP GET request to a server that I'm pre-configuring. And this is the payload that's being passed to it. So you can see I've got all this internal information state from log record. And very useful. This is the type of thing that I was thinking about would be awesome for being able to create an application stats aggregator or some sort of exception, traceback tool where you can bubble up all this information in a nice UI. In that bundle on GitHub, there's also a custom logging handler. This custom logging handler I made is basically a buffer that is 10 megabytes. And it allows us to just add messages in, and when we exceed that 10 megabyte buffer, pop off messages until we're under that 10 megabytes. And what that allowed me to do was create a Tornado-based web application that I could go and say, show me all the log entries that happened. And I could also pass in a flag as a query parameter and say, flush the buffer, because next time I make the request, I'm going to want to get everything new. An AMQP handler. So one of the things that I had said in my submission proposal was I was going to talk about an AMQP handler. We're obviously running low on time. I ran low on time and I wasn't able to write it, but I intend to do so. What I want to cover real quick, and we're coming to an end here, is logging performance. So performance can be an issue. And to figure out where that issue is, or how much of an issue it is, I wrote a quick little app using creating a Fibonacci sequence, and I tested this in Python 2.7.2 and 3.3, and I'm just using the default things in logging. I'm not doing anything special. So a baseline profile looks like this. I obtained this by using cprofile, graphviz, and dot to figure out what's going on. This is just importing logging in Python 2.7. And doing the same thing in 3.3. Now, to be honest, I don't know if the complexity in that tree is because cprofile has gotten that much better, or if 3.3 is that much more complex. Here is now setting using basic config to info with 2.7. And here's doing it with 3.3. Now in this, I'm actually using logger debug, and I'm ignoring it because I'm set to info. Here's what happens when I set level equals debug in 2.7. And here's what happens when I do it in 3.3. And here are the performance implications. So you can see at the middle of that graph at level equals info, that means I've got logging.debug going on, but my level is info, and so that logging debug is being ignored and it's not being logged. At the tail end of that hockey stick is when logging is debug, and I'm outputting, and that actually could be much bigger if you were using other logging options and you were waiting on I/O or anything like that. What does that really mean? That there's a slowdown in my code for level equals info, level equals debug. Debug logging is slow, right? 195 times, 312 times in 3.3. So what do you do about that? If you're using debug, create a flag internally that you can toggle. It's much faster to say if debug is true, then do the debug statement, than it is to rely on the logging module to decide whether or not there are any handlers that should be actually going out and logging at the debug level. Most importantly, it's moderation in all things, right? In all of our code, no matter what we do, we want to make sure that we're moderate. We don't want to go overboard, but we want to have enough to provide useful information when our applications are running. And so with that, are there any questions for me?
Hey, thank you very much. Is there any problem with using the exe info in, when doing logging calls? Or is it better to append traceback format exe or something like this?
You know, you pulled up a point that I actually wanted to touch on. There's the log exception level, which I had an asterisk for. If you get an exception and you do logging.exception, it will include the traceback info for you. And so you should drive into that and look into there. Obviously, if you're grabbing that info, it's going to create a performance impact on all of your, you know, if you're using it at the info level, for example, you wouldn't want to do it there. Yes?
Hi, thanks for the talk and the duplication of a log message thing. I'm hitting that, so I'll go take a look at it. But my question is, I have several log. I use the namespace stuff extensively, and I also have like a buffered memory logger and a file logger and a console logger.
Yep.
And I want to add colorization to the console only.
Yep.
So would I use a filter for that or an adapter, or what's the best way to do that?
There are a couple ways you could do that. You could create a wrapper around the, or you could create a handler that extends the existing stream one, or you could create a formatter. It's really up to you on where you want to inject that space. I'd probably do a formatter just because it's nice and, you know, abstracted away.
Okay, and then I actually, because my namespaces are split actually across multiple modules in my package, and I have it all broken out, do I have to create like filters for all of them, or how would I?
For the colorization piece?
Yeah.
I would probably create a logger and a handler that captures what you're looking for. Or I'm sorry, I would create a handler that captures what you're looking for, configure it at that level for your namespace across the board, the things that you want to use and don't want to use for that colorized output. The, on that front, Tornado project actually has a module that's been broken out in 3.0 beta, which was just released, that does colorization and everything for you.
Okay, cool.
So you might want to take a look at what they're doing there too.
Thanks.
Yep.
Hello. Hello. I'm doing a web application and experimenting with log aggregation. Could you mention a project or rule of thumb or general strategy for aggregation that isn't so naive of just like pure matching of maybe, you know, the message string or something? Like is there a technique or a package you recommend?
I mean, I hate to say it, I am a huge fan of Splunk. It's an awesome tool, it's expensive. There are open source, you know, implementations of similar things. People keep telling me I need to spend some time with Logstash. But you could also, within the buffered log handler, you could make that more complex, and you could extend that particular handler and make it do log aggregation and roll up pretty easily. The code's very simple within the emit method to do that.
Thank you.
Yep. Thank you.
Hi, I have a question. So one of your slides showed that you use different things like Django, PsychoPG, and you have different levels of logging. Or
right.
How do you integrate all the different logs together?
Actually, most of what I use is syslog. So I use usually I've got a console handler for when I'm writing things at a debugging level, and then I use different handlers for different things, primarily syslog. For files, if I am using file-based, I tend to want to use the rotating ones, and I'll create multiple handlers for the same logger that output to different destinations, as a primary focus on that, if that answers your question. All right. Thanks. That doesn't work very well. So one of the nice things about logging is it provides a consistent output method. This same code refactored allows me to send debugging information to a place that I want debugging information to go, exception information to a place where exception information should go, and error information to somewhere else as well. Another nice feature about logging is it allows us to avoid not invented here syndrome. I was working on fixing some issues in a very well-known Python application, and I saw that they had logging.debug, logging.warn, logging.info. I'm like, awesome. I'll go in and I'll just figure out where they're instantiating their loggers and fix that and get the logs go where I want them to go and logged how I want them to go. Well,
Good afternoon, everyone. Let's all welcome Gavin.Roy, who's going to teach us how to become a logging expert in 30 minutes.
Thank you. I have to say, it's pretty cool being at the end of PyCon or the next to last talk track, because I've got to see lots of really cool material, so I hope I live up to a lot of the talks that I've already seen. How do you become a logging expert in 30 minutes? Well, it's hard to do, but what I want to do is I want to dive into the logging module, something that oftentimes people tend to touch, do things with, but maybe not understand the full stack of everything that's going on. And so I have a lot of information here. I'm going to try and see. They decided somewhere in the life of their project that they didn't like the logging module, and so they wrote their own. And it was hard-coded to write everything to one file on one path, and you couldn't change anything about it. Another nice feature is the fact that it has configurable destinations, and that was one of the things I was trying to achieve, was fixing in this project, allowing for configurable destinations for the various things that I wanted logged. I wanted exceptions to go into a specific file, so it was easier for me to figure out what's going wrong and fix it. And I wanted informational messages to go into syslog, so I could use Splunk to go and figure out trends within the application and that sort of thing. So if you just look around this, you could see you can send to everything from files that rotate on disk, configurable. In fact, it's so configurable that some might say it violates the Zen of Python, because it can be complex, and it can be complex to the point where it's intimidating. But you might see this common pattern in things. I actually went to one of the oldest apps I wrote in Python and published on GitHub and pulled code out, and this was the code. You can see I've got commas, for example, in my exceptions, so that probably shows you that it's older than it should be. But what I'm doing, as you can see, is I'm printing when I want to debug things. I'm writing to standard error when I have an error, and that's good for running things interactively, but when it comes to putting your app in, squeeze it down to 30 minutes. And if I rush through some things, I apologize. I'm happy to answer questions after. I work for MeetMe. We are a social network focused on social discovery, and we're located on the East Coast, and we're hiring, and they were nice enough to send me here and sponsor PyCon. So if you're looking for a job, you're interested, please get in touch. The content examples and SVGs from my talk are hosted on GitHub, so as we go through the examples, again, if it's too quick or you want to check something out later, feel free to go over to that and grab it. Why should you use logging? Number one reason is it's highly